Hey guys, today we're going to take a look at geometric sequences. So a geometric sequence is a list of numbers or a sequence of numbers that has a multiplying pattern. So that's the key thing to know or understand about geometric sequences. And that pattern is called the common ratio. And we usually use the letter R to represent the common ratio. So let's look at a couple of sequences and how we'll find that common ratio. So example 1, let's say you have 4, 8, 16, 32, and so forth. Now I can look at this and see that I'm multiplying by 2, but if it's not clear, if you can't clearly find the common ratio, you can take the last number and divide it by the number in front of it. So for example, 8 divided by 4 gives me 2. 16 divided by 8 gives me 2. 32 divided by 16 gives me 2. So you can divide to find your common ratio. Look at another example. Let's say we had 7, negative 14, 28, negative 56, and so forth. So I can look at it and tell that our common ratio is negative 2, but again, if you're not sure, you can divide to figure it out. So negative 14 divided by 7 is negative 2. 28 divided by negative 14, negative 2. Negative 56 divided by 28 gives you that common ratio of negative 2. Sometimes you'll see something that looks like this. The numbers will appear to be getting smaller, or they will be getting smaller, and it looks as though you're dividing. Well, actually, in this situation, so like if you type in 50 divided by 100, you'll get 0.5. 25 divided by 50 is 0.5. I want you guys to write that as a fraction. 0.5 is 1/2 as a fraction. So that's one thing that you're going to do in this lesson. Now, just like arithmetic sequences, geometric sequences have some formulas that go with them. So you know we have explicit formulas and we have recursive formulas. Okay, so again, an explicit formula will help you find any term or any number in the sequence, and a recursive formula will help you find the next number or the next term in the sequence. And here you go. So the explicit formula for geometric sequences is a sub n equals a sub 1, which means the first term, times your common ratio to the n minus 1 power. Okay, so for example, if I'm trying to find the fifth term, I would do the first term times the common ratio to the fourth power. So you subtract the number that you're trying to find, the term you're trying to find by 1. And then your recursive formula is going to be a sub n equals r, or your common ratio, times a sub n minus 1, which is the last term. And a sub 1 is going to be your first term. So again, just if you need it, a sub n is the number of the term, like a sub 5 would be the fifth term, a sub 10 would be the 10th term. And this a sub n minus 1 means your last term, or the last number in the sequence. So let's look at how this could be used, how these formulas could be used. So one way that you may see this is I may give you, or they may give you, the sequence, and they'll ask you to write the formulas. So first we have to find the common ratio, and then we're going to write each of the types of formulas. Let's see. So, recursive. So I noticed that we're multiplying by 4. So my common ratio is 4. So looking up here at my explicit formula, I'll do a sub n equals, I need a sub 1, which is my first term. Remember, this is first, second, third, fourth term. So I'm going to put 3 times, looking back here at my formula, I need my common ratio, which we said was 4, and then I write n minus 1. So that's my explicit formula for this sequence. Now let's do the same thing for the recursive. You write a sub n equals, looking here, it says the next thing we write is our common ratio, which we found to be 4, times, and in this case you just leave it as a sub n minus 1. That just means keep multiplying by 4. And our first term in the sequence is 3. So that's my explicit and my recursive formula. So that's one way that you may have to do this, okay? But then I might give you the formula and ask you to write certain numbers. So for example, if I give you a sub n equals -4 times 3 to the n minus 1 power, and I say find the first 4 terms in this sequence, okay? So I want you to write the first 4 terms. Well, if you use what we know about explicit formulas, this is my first term. The -4 is my first term. And then it says to multiply by 3 to 1 less power. But if you really think about it, that's my common ratio, right? So watch this. I can just keep multiplying by 3. So -4 times 3 is -12. -12 times 3 is -36. And -36 times 12 is -108. That's how you can use it to find like the first 4, the first 5, or however many terms. But what if I ask you to find the 10th term? Then we use this formula a little bit differently. We plug in -4 times 3, and then it says n minus 1. Well, my n in this case is 10, so 10 minus 1 is 9. And then I type this in the calculator. So I'm going to do, -4 times 3 raised to the 9th power, and I get -78,732. -78,732. So that's how you use those formulas for your bigger numbers. Let's try another one of those. So take a look at this formula. A sub n equals 3 to the n minus 1 power. And again, I want us to find the first 4 terms. Well, based on what we learned, this looks like an explicit formula, and the first number is our a sub 1, or our first term, but there's nothing there. So think about our work with exponential functions. If there's nothing there, there is something there. It's an understood or invisible 1. So my first term in this sequence is 1. And then what's my common ratio? I multiply by 3. 1 times 3 is 3. 3 times 3 is 9. Oops, didn't mean to write times. 9 times 3 is 27. So those are my first 4 terms. But what if I want to find that 10th term again, or the 20th term? Well, then I need to plug these numbers into my formula. So a sub 10 equals 3. N minus 1, well, n is 10, so n minus 1 is 9. So I'll go over to my calculator, and I'm going to type in 3 raised to the 9th power, and I get 19,732. 19,683. 19,683. So it appears to me that these explicit formulas really are good for higher number terms. Let's do one more. What if I give you a recursive formula like this one? Let's say I give you a sub n equals a sub n minus 1 times 2, and I tell you that the first term is 2. Now, I can easily find the first 4 terms, like I did in the last 2 problems. So the first 4 terms, the first term is 2. Well, it tells me to multiply by 2. That's my common ratio. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. But look at what happens if I ask for something like a to the, let's do 10th power for this one as well. With a recursive formula, I have to just continue on that pattern. See, I have the first, second, third, fourth. Now I need to find the 5th, the 6th, the 7th, the 8th, the 9th, and the 10th term. So I'm just going to keep on going, okay? So my 5th term, 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. See, I'm just continuing using that pattern, my common ratio. 128 times 2 is 256. 256 times 2 is 512. 512 times 2 is 1,024. So now I have my 10th term as 1,024. So again, I feel like explicit formulas help you find the bigger or the higher number terms, and recursive helps you find like the first few terms in a sequence. But be careful. In this lesson, use these notes to help you identify if a sequence is a geometric sequence, find the common ratio. Then for some of your problems, you're going to have to write either the explicit or recursive formula. And then in some of your problems, I'm going to ask you to use formulas to find certain terms. So I'll talk to you guys later. Bye.